Hello, and welcome to a special Halloween themed SETI Live. I am your host, Beth Johnson, and joining me today is the esteemed Seth Shostak. We are here to talk about all the ways you can die on other worlds. So we're going to get spooky. Let's have some fun, everybody. All right, Seth, how are you doing?
Well, I'm still alive, so I guess it's only because I haven't been to any other worlds.
I,
But
I
otherwise,
think
it's okay.
I think that's true, right?
It is true, actually. Yeah.
So, how should we start our tour of death in outside of Earth? Uh, Want to start in the inner solar system? Shall we start with Mercury? How would we die? What would kill us on Mercury?
Yeah. The trick, Beth, is not how to die in space, it's how to stay alive in space. That's a lot harder. It's really easy to die because, the universe, it looks great in those Hubble photos or the JWST photos. It looks really nifty. But if you're actually out there, you realize the universe is just out to get you, and it probably will. Well, Mercury suffers from a couple of things. To begin with, it's very light, and that just means you don't weigh very much. That's not necessarily a problem. You'd be a lot stronger relative to what you would be on Earth because you could throw golf balls a lot farther away. But the real problem with Mercury is there's no atmosphere. I mean, in terms of life. So, you're going to be dead in about 30 seconds from asphyxiation. So that's not so good because it doesn't allow you enough time to make, photos to send to your folks back home.
Oh, wow. Yeah, no, that would do it. Well, okay, so Venus has no atmosphere. It's also pretty warm. Um, Lifeless, clearly. But Venus has an atmosphere. What's going to kill us on Venus?
Yeah, well, on Venus, it's, I mean, there's a lot of, sulfuric acid actually in the atmosphere, apparently, but I don't think that would get you. It might ruin your clothes. Uh, it's true. Venus has 100 times as much atmosphere as the Earth does, but there's not much oxygen in it. It's all carbon dioxide, almost all carbon dioxide. And if you've ever tried to breathe carbon dioxide, I mean, you know that it's not very gratifying. I mean, plants do it, of course, but they're plants, right? So that's the big problem on Venus now. You're right. It's also hot. At the surface, it's about 800 degrees. And whether that's Fahrenheit or centigrade, I don't remember. But when it's 800 degrees, you don't have a whole lot of time to think about that, right? Because 800 degrees, it's it's like being in your oven on broil. So that's not so good. But there's this saving grace, if you will. If you just go up above the surface high enough, maybe 20 or 30 miles, then the temperatures are about the same as they are in this lovely office here. Okay, you can tell it's lovely because of all the stuff on the walls. So, all right, so 25 miles up, it's nice temperature. There's still no oxygen to breathe, however. So it's most likely that what will get you on Venus to begin with is the heat and then the asphyxiation. And all of that means that you're going to be, you're going to be checked out within about 1 minute.
Well, you've lasted 30 seconds longer than on Mercury, so I suppose
Yeah.
we're getting better. Um, okay, how about the moon? What kills us on the moon? I mean, we've sent people there. We know people can manage. You got to have a spacesuit, but other than that, what's happening?
Yeah. Well, on the moon, actually, it's, relatively speaking, not any worse than the other places. At least it's not, I mean, it's very hot in the sun and it's really very cold. Hang on. It's very cold actually in the shade. So, you got to be careful. One side of you will be subject to this extreme heat, and the backside will be extremely cold. But again, there's nothing to breathe. I mean, the atmosphere on the moon can only be measured by instruments. There's very little atmosphere. So you have to have the spacesuit. Now, that doesn't mean you're safe because on the moon, you're subject to all these particles that nature generates out there. To begin with, the sun, occasionally boils up a little bit. It has storms on the sun producing all these high speed atomic particles, most of which doesn't bother you because you live on Earth, which has a big magnetic field and an atmosphere. So pretty much protects you from all that. But on the moon, you wouldn't be protected at all. So there'd be all these, atomic particles zipping through your body at very high speed. And that would give you fatal, well, it would cause cancer that you couldn't recover from. All right. Now, of course, that doesn't mean you're going to die immediately because the cancer is going to take a while to do you in. But you're really a dead man walking if you don't have protection against those particles.
All right, so that's as far as humans have made it off of Earth, in fact. So I'm going to take a moment to greet some of these humans who are in our chat. One moment here. Let's see. Someone is watching from their kitchen. Thank you for that. Oklahoma, Australia, Cape Cod, Chile, Sweden. Thank you for watching from Sweden. Scotland, Michigan, Poland. Wow, another person from Sweden. Wow, we got a couple Swedes tonight. Denmark. I know that's a friend from Mexico, Germany, more Poland. Lots of people from Poland. Canada, Mississippi. Wow. Okay, so we've got a lot of it's very global going on here. And let's see. Yes, happy Halloween, everybody. Happy Halloween. So I'm here with Seth. We're just talking about ways to die in the solar system on other worlds. We'll probably get out of our solar system in a little bit. It's Halloween here in the United States and everywhere else that is interested in this kind of holiday. So we thought we'd do something different and spooky and silly. So don't expect seriousness in this one, guys. All right, we've gone to the moon. We've actually successfully gone to the moon. The asteroid belt. Can we land on an asteroid? There's talk of mining them, but I think that's more of an automated process sort of thing. But can we physically land on an asteroid? Is that even possible?
Yeah, I think it's possible. I mean, we've sent recently the DART mission sent a spacecraft to an asteroid, in fact, but it just crashed into it, and that's not what you'd want to do. But because they're so small, I mean, most asteroids are small. I don't know how many asteroids you have at home there, Beth, but most of them are pretty diminutive.
Tiny pieces. I have tiny pieces.
Do you have tiny pieces? Okay, well, I mean, an asteroid, it's sort of a kind of a litter pile that's big enough to have formed into a ball because of its own self-gravity. And again, no atmosphere. But on the other hand, you could land there. It's really easy to take off from an asteroid because the gravity is so weak. You don't have to fight that. And in fact, there's quite a bit of speculation in the literature about how humanity's future is not on Earth and not even on Mars or the moon. Those are all great. But, if you completely populate Mars is a small planet, you only get, double the amount of acreage that we have today, double the number of hectares that we have here on Earth that are inhabited. So that only helps you until, the population doubles again, right? Then suddenly Mars and the Earth are just not enough. But the asteroids have a lot more square meters, a lot more acreage. And that's because, right, I mean, take a ball of clay, say that's, a planet, chop it in two, roll up each of the halves, and you'll figure out, this is high school geometry, in case any of you ever took that, high school geometry, you'll find out that suddenly you've increased the surface area by about 26%, right? Well, don't stop there. Just chop each of those balls in half, and, you increase the surface area again by 26%. So you don't have to do this exercise because nature has done it for you. These are called asteroids, these little things. And there's lots and lots of acreage here, a lot more than you'll find on the planets. So people say, well, our great grandkids will all be living on asteroids. And, I don't know what the life on an asteroid would be like. There'd be maybe some good views. No, there won't be any good views. In the movies, when you see them going through an asteroid belt, you've seen this 1,000 times, Beth, right?
Mm-hmm.
They're trying to maneuver their rocket ship through the asteroid belt, and it's rocks. It's like, I don't know, it's like a slalom course for skiing. But in fact, the asteroids are not all that close together. If you're on one asteroid, the next asteroid might be 1,000,000 miles away, and it's just a small rock. So, it doesn't look like much when you look at it. So, I mean, there's not much to do on an asteroid, but there is all that square footage. So maybe you'd have to build, you'd probably want to dig something. You want to dig a hole that you could live in, a cave of some sort, again, because of the particles in space that would otherwise give you cancer for sure.
But you're still trapped in a spacesuit.
Well, you are, unless you can build an underground habitat with airlocks, and then you could, sort of have an artificial environment down there, so you could walk around, uh, do crossword puzzles, play games, whatever. You could do it. I, I know life on an asteroid. Um, I don't know about you, but to me, it's not even. I mean, it's not nearly as nice as life in New Jersey, just to name something.
It seems like a very solitary life, really.
It
I'm
is. You're kind of
I'm on
alone.
an asteroid, and no one else is here with me.
No, no, no.
All right, so moving further out, uh, we have ambitions to go to Mars. We've got it's the only planet populated by robots that are still working. So they seem to be doing okay-ish. What would happen to us if we were there? Is it very much like The Martian? Is it lots of habitats and dust storms that will kill you? What's happening on Mars that we need to worry about?
Well, all of that is true. And in fact, if you want to know more about Mars, just pay attention to what the SETI Institute does. I think 80% of the people here, maybe even more, work on Mars, right? The reason for that is that Mars is everyone's favorite inhabited planet, right? There are Martians everywhere in books, movies, radio shows, television, movies. Mars, Mars is great. And that's because of the history. Mars, if you think about it, it's the only planet you can see from Earth with a telescope where you can actually see any surface markings that are really part of the surface. Not like Jupiter, you see a bunch of stripes. Saturn, you see a bunch of stripes, but that's all in the atmosphere. You're just looking at stuff in the atmosphere. On Mars, you actually see the ground, right? And so when that was the case, people immediately took interest in Mars because it's very close, relatively speaking, not quite as close as Venus, but almost. And it has an atmosphere and it has polar caps, right? Little white spots at the top and the bottom. Clearly, there must be some sort of atmosphere on Mars to make those polar caps with water vapor in it. Actually, the polar caps are not just ordinary water ice, but quite a bit of CO2, which is dry ice, right? Okay,
Mm-hmm.
but from the beginning of modern astronomy, which say dated from 1600 or something, when we first started to use telescopes, Mars was the thing. That was the place, right? Venus, you don't see much except, a little white crescent. There's nothing to see. But Mars, you do see something. And of course, that became of great interest about 160, 70 years ago when an Italian astronomer by the name of Schiaparelli, um, Schiaparelli. For those of you into pizza, Schiaparelli had nothing to do with pizza. Anyhow, he was an Italian astronomer. He looked at Mars, through the telescopes of the day, and he could see dark markings and so forth. And in addition to that, he thought he saw channels, canals,
Mm-hmm.
right? He used the word canali, but that's because he was Italian, right? And canali could mean channels or it could mean canals. Nobody knew. But around 1900, a fellow by the name of Percival Lowell, an American astronomer from Boston who had gone to Harvard. In fact, his brother became president of Harvard for a long time. Percival Lowell, who was said, by the way, to be the smartest student that Harvard ever had. And I don't know if that's true, but on the other hand, it was only Harvard, so it really doesn't matter too much. But in any case, he he took this Italian result very seriously, and he built an observatory in Flagstaff, Arizona, modestly named it the Lowell Observatory because that was his name. And Percival Lowell wrote books and he gave talks and all that sort of stuff about the Martian canals because he could see them. And he said there was this big civilization on Mars, and they were digging all these canals just to bring water from the polar regions down to the closer to the equator, where they would grow their spinach or broccoli or whatever it is that Martians eat. So Mars looked good for a long time. But while Percival Lowell died, still believing in the canals on Mars, most astronomers by then didn't believe it. I think he died in 1916. In any case, they were learning that the Martian atmosphere is very, very thin, right? So, you can't, and no oxygen and so forth and so on. So Mars may look good from far away, but if you were actually on Mars this weekend, you would find it very trying. You couldn't breathe and you'd probably freeze. Other than that, it's good.
How about those dust storms? Are they as powerful as we have been led to believe by science fiction?
Well, they do have dust storms all the time, and in fact, dust devils and so forth. You can find NASA photos. The dust devils are so commonplace that they show up in some of the photos. Well, the thing about it is this: yes, the wind's moving really at quite a clip. I don't know, something like 150 miles an hour, 200 miles an hour. I don't know, but something like that. And you would think, oh my God! I mean, imagine being in a wind at 250 miles an hour, right? It just blow everything apart. Your house would just be blown into the next state.
Hmm.
Um, but the thing is that Mars's atmosphere is about 100 times less dense than Earth's atmosphere. So it's moving very quickly, but it's a very thin atmosphere. So in fact, wouldn't even ruffle your hair if you have hair. I mean,
Okay, so not as windy as we thought, just not as effective a wind as science fiction leads us to believe. All right.
yeah, it moves the sand around quite a bit. If
Well,
that's of interest.
that is definitely of interest because we have lost some landers and rovers to that because we can't send them up with something to brush all of the sand off of their solar panels. So when the dust and sand gets too thick, we lose them. We're losing insight right now because of that.
Yeah.
So yeah, that's the hard part of trying to be on that particular planet is dust gets in everything. I'm going to take it before we move into some gas giants here. Let's say give some shout outs. So let's see, we've got more Mexico, Antwerp, very cool. Italy, Seattle, London, Portugal, welcome. Upstate New York, more Canada, more London. Let's see, I think more Canada, Connecticut, welcome, welcome. Some more from England. Okay. And Florida. Cool. All right. Thank you, everybody, for joining us. Once again, we are having some holiday fun here on SETI, on our SETI Live, talking about how to die on other worlds. So we've covered the inner solar system, we've covered the asteroid belt. Now we have gas giants. Now, I don't want to spend a lot of time on the gas giants themselves because there's not a lot of like surface that you're going to experience. But let's talk about, say, Jupiter and what would happen if you tried to reach the actual physical surface underneath the very thick atmosphere. What's going to kill you here? Probably
Well,
the atmosphere, but give us a few reasons that you're dying on the way down there.
yeah. Well, indeed, the atmosphere is not very. I mean, come on, the atmosphere's nice and thick, but it isn't an atmosphere you'd want to breathe. I mean, it's got what ammonia and methane and stuff like that. I mean, gosh, I mean, who wants to breathe that? I don't. I mean, I tried breathing it for a couple of weeks. It wasn't any good. So, and the real problem is, as you just said, Beth, there's no clear surface on Jupiter. When you look at Jupiter, you see all these stripes, and you think you're looking at Jupiter, but what you're looking at is the atmosphere around Jupiter, which is enormous, right? Okay, so if somebody threw you into Jupiter, I mean, just as a prank, I'm going to throw you into Jupiter. All right, you would go in, all right, and what happens is that it gets warmer, believe it or not, because of the pressure and so forth. So you've got that. It's unclear that you would ever hit anything. You might. There seems to be a sort of a metal core to Jupiter, a metal ball, a ball of metal. Maybe that's a better thing to say. And of course, if you hit that, that'd probably wipe you out. But you'd probably be dead long before that because you can't breathe that atmosphere. And it also gets very, very hot. We've tried this experiment. One of our orbiters, which one was it? Galileo, I think was the name of it. Yeah, the Galileo orbiter. It threw itself into the atmosphere of Jupiter at one point. The spacecraft did, and we haven't seen it since. Now, if anybody has found it, contact NASA headquarters because I think that there's a $35 reward for the return of that Galileo spacecraft. But, it went into Jupiter and presumably met an unfortunate end, as would you. So forget the planet Jupiter. I mean, it's nice to look at, but, it's just too hostile.
Okay, well, Jupiter and this the same thing is probably true for Saturn, Uranus, and Neptune, right? You're gonna have the same exact problem. Thick atmosphere, not breathable, will kill you on the way in. Not, but they have a lot of moons, these worlds. So let's talk about some of these worlds. Are any of these? Is there any possible? I mean, do we have any that sound good? How about let's start with the Galilean moons. Let's start with Ganymede, biggest one. What's going to kill you on Ganymede?
Well, Ganymede. I mean, indeed, the four moons that Galileo himself saw in 1609, and you got to give him credit. He could have mistaken them for just faint stars, except that he noticed this was the genius of Galileo. He noticed that those four little stars sort of moved with the planet every night as the planet was moving around the sun. So he knew they weren't just background stars. Uh, yeah, well, Ganymede, did you say Ganymede?
Yeah.
All right, I think Ganymede's the biggest or the second largest, one or the other. It's bigger than our own moon, but not by an enormous amount. So you know, again, no atmosphere on Ganymede to speak of. It's going to be really cold. I mean, not only is the lack of an atmosphere makes it cold because there's nothing to sort of keep the heat in, right? Those of
Mm-hmm.
you who live in, for example, the South know that at night, even though there's no sun in the sky, it doesn't get cold. It stays warm because the atmosphere is, keeping you subject to all that heat.
Mm-hmm.
Now, on these moons of Jupiter and Saturn, there's no atmosphere to speak of. So that means that at night it just gets really cold. So you'll die there, but you'll die of asphyxiation first, as is so often the case. The real problem with space is it's hard to breathe, right? There aren't many places. There are no places we know of where you could actually just breathe, right? It's not like on Star Trek when Captain Kirk gets out of his spacecraft and wrestles with some sort of strange alien creature, and they're both just breathing away as if the atmosphere was just perfect for that. It wouldn't be. I mean, no place we know of is the atmosphere okay for you to breathe. So modify your Christmas vacation plans accordingly.
All right. Well, okay. So it's established that if we want to land anywhere, spacesuits are definitely a must, if it's even possible. What about let's move on then. As much as I would love to discuss Io and its fabulous volcanoes, clearly also not a good tourist spot because it's the lack of oxygen is going to kill you. So let's talk about Titan. Is Saturn's moon. It has an atmosphere. What's going to kill us there?
Yeah, Titan. Yeah, what is going to kill you on Titan? Well, the atmosphere again is the wrong kind. What's in Titan? It's a very acidic atmosphere. Actually, it's a very thick atmosphere. Unlike, for example, on Mars, the atmosphere in Titan is pretty thick, but it kind of rains, acid. It sounds like something out of a horror film. We're going to put you in this room where the sprinklers are going to spray acid on you until there's nothing left of you. Well, I mean that's kind of what you would experience on some of these moons, certainly with Titan. Um, but it does have an atmosphere. It's a very thick atmosphere. In fact, the fact that it's called Titan is why. Well, because it was thought to be bigger than any of the other moons of Saturn, but that's only because it has this thick atmosphere, which it's like wearing a thick coat. It makes you look bigger, and it isn't actually all that big. Anyhow, yeah, we've seen it. It has rain, but the rain is the wrong kind. It's not liquid water. It's just another loser of a world. I mean, there are just so many losers. It's like my experience with lotto tickets, right? They've all been losers.
Oh, I feel that so much. Something Powerball. Anyway, um, Sabine, thank you very much for the stars over on Facebook. Much appreciated. We would throw that up on screen, but Facebook doesn't play nicely with us. So once again, to remind everybody, we are a nonprofit, so we are supported by your donations. And those donations can come in the form of bits on Twitch, subs on Twitch, super chats on YouTube, and stars on Facebook. So all of those things help keep us doing silly stuff like this, which, we are talking serious science here. We're just having some fun today. All right, so Titan is a world with an atmosphere and liquid rain, but not something that we can use really for us.
No.
All right. Okay.
No winners so far, but
no winners so far, and that really was kind of like our best option there for a moon, right? Anywhere in the solar system. So the gas giants we've established suck. How about, and I'm going to cause controversy, but how about Pluto? What's going to happen with Pluto and its sister Charon?
Yes, Pluto and Charon is sometimes called a double planet. Well, Pluto. They say if you're going to sell your house, what counts more than anything else is location, location, and location. Well, in the case of Pluto, that's the problem with Pluto, location. It's it's out there in the Kuiper Belt. It's at the edges of the solar system, and as a consequence, it's really cold all the time. I mean, really cold. I mean, minus 150, minus 200. I don't remember, but it's cold. I've talked to people who've been there and back, and they say it's really cold. So don't plan on going to Pluto. Again, also no atmosphere to speak of. So yeah, it's not very. I mean, it's got ice mountains if you're into that, but it's hard to ski on ice mountains, right? The surface is very solid. This is not the kind of slushy ice that you may pick up at a fast food restaurant and pour some strawberry sauce on. This is really solid ice. I mean, it's harder than granite. Okay, so there's that problem. However, it turns out that because of the interaction with its big moon Charon, the planet gets sort of squished and squeezed and squished and squeezed. It gets kneaded like you knead a ball of dough if you're making bread, and that heats it up a little bit. So there's occasionally there are places where there's actually some liquid water on Pluto. So despite the fact that it's very far from the sun, so really cold, despite the fact that it doesn't really have any atmosphere, there might still be life on Pluto, microbial life, right? Because of these little sort of pools of water that form under the ice. But it wouldn't be good for humans. I mean, it would be a great address, right? I mean, you imagine how much that would impress your friends or the people you meet at the next cocktail party you go to, if you go to those. It would really impress them. Well, I live on Pluto. I mean, other people are saying Philadelphia, Trenton, New Jersey, or Bristol, Pennsylvania, but you could say Pluto, and that would be good until 1 minute later when you're dead.
Okay. Well, you mentioned, and that brings up an interesting point. Before we move out of our solar system, you mentioned that there could be microbial life because on Pluto because of the liquid oceans that are subsurface, which was somewhat of a surprise. But we also think that that's also the case with Ganymede, Europa, and Saturn's moon Enceladus. So how is that possible? How can life survive on these worlds where there's no atmosphere, but we are talking about an ocean? So what's going on that makes this possible?
Well, I mean, you just have to think about what life is. It's something you probably think about a lot, actually. What are you going to do this weekend, Bob? Well, I'm going to think about the meaning of life. Okay. Well, life is just organic chemistry, right? That's basically it. And so, if you want to do chemistry, it helps to have a liquid, only because otherwise, all the elements, they're sitting around. I mean, imagine an old chemistry set for those of you who remember chemistry sets. You have all these various things in bottles and so forth, but they don't do much. You can pour them out. You can pour them onto the living room rug. I mean, that'll antagonize your parents, but they don't do much until you throw some liquid on it. You throw, a glass of water on it. Maybe they will do something. So liquids are good for that. What was the question again?
How can life survive in the
Right.
subsurface oceans of some of
Yeah.
these worlds?
Well, look, all you need for life is you need some chemistry. So you need the chemicals. That's not a problem. The 92 elements you were forced to learn about in high school, you find them everywhere in the universe. So they're around. But you also need that liquid. You need the liquid in order to get the chemistry going. It's one thing to have the ingredients, it's something else to have reactions. So, you want liquids. You also don't want it to be too terribly cold because the reactions go very slowly. So it's better to have water that's, liquid. All right. So you have that. But you might say, well, yeah, but on Earth, everything lives thanks to the sun, right? You have a steak tonight, and that steak came from some critter, and that critter was eating grass, and that grass was growing because of photosynthesis, because of the sun, right? The sun's energy made all that possible. So you're eating sun energy when you eat that T-bone. Okay, fair enough. And you might think, well, if there's a subsurface ocean on a moon like Europa around Saturn, how could you have any life? Because the sunlight can't get through. It's absolutely pitch dark down there. There's another source of energy you could use, and that's just, bubbling hot stuff coming up from the center of the moon or planet, right? So the center of these moons, the four big ones, are pretty warm, mostly because, again, of this sort of stretching and squishing that happens because they're orbiting Jupiter in a funny way that causes that. So you get some source of energy, and the moons have to get rid of the heat, and they do that by, bubbling up stuff. You could have some of that heat could support microbial life. I mean, it's not impossible. They'll never be where the sun shines. They'll never see the sun, but they could still live. I mean, they're microbes living, 3 kilometers down below the surface of the landscape here in Mountain View, and they don't ever see the sun, right? They don't have to wear 20x sunblock or anything like that. They're never going to see the sun, and yet they're alive. It's not a great life. They never go to the movies, but they are living there. So you could have life.
So we found life like that on the ocean floors of our world. So, around what we call hydrothermal vents, black smokers. They're volcanic. They're full of minerals and hot water, and we've actually found microbes and other larger things living around them. So this is a distinct possibility, and kind of, I think, where a lot of our hope rests right now, aside from digging down underneath the surface of Mars.
Yeah.
That pretty. Go ahead.
No, I was just going to say, we're not very far from one of the NASA research centers here. NASA Ames Research Center is only about 2 kilometers away from the SETI Institute. And there's a guy over there, Chris McKay is his name, but he's a very well-known Mars researcher. But the last time I saw him, he said, Shostak, I'm not studying Mars anymore. I said, what? And he said, no, he switched his allegiance to Europa, right? Some of the moons of Jupiter and Saturn, and Enceladus. He thinks these are better places. You have a higher probability of finding life in these places than even on Mars.
Well, that pretty much covers our solar system. Are there any interesting ways to die on exoplanets that could be different? I mean, aside from the lack of atmosphere, we've seen worlds that are raining diamonds. That could probably not be fun. Pretty, but not fun.
Yeah. Well, there's some stars that actually are diamonds, big diamonds. Doesn't do you any good, though. I mean, they might be worth a lot on paper, but you're never going to be able to sell them. Yeah, well, outer space, I mean, it has all the same problems that we find in our solar system. And in addition to that, there are other things that can happen to you. For example, a star could explode in your neighborhood, right? You have that happening. Novas, supernovae, and they blow up in the, I mean, if you're anywhere nearby, if you're within maybe 5 or 10 light years, it's going to strip away the atmosphere of your planet. And then you're going to die with all the usual problems. So there are things out in space that we don't experience right here. But, here's another one that most people haven't thought about, actually. There's a lot of dust in the universe. There's a lot of dust in my house, but there's a lot of dust in the universe. And those of you who pay attention to, for example, the photos coming down from the James Webb Telescope recently have seen all the beautiful photos of all these dust clouds in the Milky Way. Okay, there's all that dust. Now, most of the dust is constrained to the plane of the Milky Way, the flat plane of the Milky Way. And the Earth and the Sun, we're orbiting the Milky Way once every 250 million years. I remember last time we were here. So it's going around, right? But it's not exactly in the plane. We go up and down sort of through the plane. And if you hit a dust cloud, like one of those you see the James Webb photos, right, then that dims the sun a little bit, right? Just a lot of dust. It's like smog in Los Angeles, except this is dust. It's not quite the same as smog, but it has the same effect. And it dims the sun, and maybe we'll all die because of that. I mean, that could happen. I don't recommend it.
Wow. Okay, so more ways to die. All right. Well, Seth, this has been a joy as always. Thank you so much for taking time out of your busy day to be a little silly with me. Much
Not just a
appreciated.
little.
And thank you to everybody who joined in the shenanigans and watched us be, have a good time. So the conclusion here is that Earth is good. We love Earth. Let's take care of it because we can actually survive here. So Yay. Um, Once again, thank you everybody for watching. Thank you, Seth, for joining me. And as a reminder, we are a nonprofit. So if you have a moment, go over to SETI.org, click on the Give Now button, and support our science programs and our outreach programs. It is greatly appreciated. We will be back. I will be back Thursday to talk to my friend Jessica, who I actually know from grad school, which is pretty neat, about marshmallow worlds and puffy planets. So come join us on Thursday at 2:30 p.m. Pacific, 5:30 p.m. Eastern. Thank you once again, everybody, and have a happy Halloween.